In this example, students in years 2 and 3 of a forensic science course all sit a short test based on a particular topic, and their percentage marks for this test are given as T1. All the students then receive some additional classes on this topic and sit a new test based on the same topic, getting results T2. We wish to test the effectiveness of the additional classes on the two year groups, and to do this we will use a repeated measures ANOVA, general linear model repeated measures. Within this data, the subject is the year group, and we're interested in the change of results within the subject, so we will give this a name. So we will call this test difference, and there are two levels, the before and after tests, and we will add. We're also interested in the effect on the two year groups, so we will enter the name year group and add. We now need to define these, and so the two levels of the within subjects variable are T1 and T2, and the between subjects factor is the year of the student. We now run the test. One of the output tables is the test of between subject effects, so this is testing whether there is a difference in the overall results between the two years. And in fact, for the factor year, we find the p-value as less than 0.0005, showing that there is a very significant difference between the overall performance of the 2 years. However, our main interest is in the within subjects contrasts, i.e. the significance of the difference between the two test values. So if we just look at the test difference itself, we see a significance value p of 0.927, which says that overall between T1 and T2 there is no significant difference in the mean values. So that grouping together years 2 and 3, the additional classes do not appear to have made any significant difference. However, the most interesting factor here is the interaction term between the test difference and the year of the student, and we see that that is significant. The p-value is 0.016, showing that there is a difference between the change in test results depending on the year. We cannot tell at the moment what this difference is, but we just know that years 2 and 3 have reacted differently to the additional classes. We will investigate this difference by actually calculating the differences involved. So we will use transform, compute variable, and we will create a new variable T2 minus T1. So we will calculate the difference between T2 and T1, and that expression will be T2 minus T1. Okay, this has created the new variable T2 minus T1 in the fourth column, and we will explore this data using Analyze, Descriptive Statistics, Explore. T2 minus T1 is the dependent variable, and we will investigate it for the different years. The results show us that T2 minus T1 for year 2 shows a drop in the mean value, dropping by 1.35, whereas for year 3 the mean value has increased by 1.25. This shows that the additional classes have had a positive effect on the score for Year 3, but possibly because the topic was too complicated, the additional classes only served to further confuse the Year 2 students, giving a reduction in their scores.